How you going, guys? Curtis from Cutting Edge Engineering. Today's job, we have some custom tooling to make for a customer. What we're going to be manufacturing today is a bearing puller. What it's designed to do is to remove the cone out of a tapered roller bearing. If you're unfamiliar with what a tapered roller bearing is, they make up of a couple of different parts. There is a tapered cup that fits over the roller bearing arrangement. Removing the bearing cup out of the housing is very, very easy. A little bit of heat is applied in a couple of different spots. That will shrink the bearing cup and it will basically just fall out. You have your bearing cage, which holds all your rollers in place, and then under the cage you have your bearing cone. When this is assembled in a machine, that's generally mounted to a shaft. That is a interference fit on the ID. The cup is then mounted into the housing, which is also an interference fit on the OD, and then that makes up the bearing. There'll be one on the bottom and generally one up the top, depending on whether it's a wheel end, a final drive, or a drop box or something like that. The only way to remove the bearings after they have been worn out, you have to cut through the cage, top and bottom, open that up, get rid of all your rollers, and then you then have access to the inner lip that retains them from coming up. Once you have access to that inner lip, you can then remove the bearing cone. The issue is trying to remove that cone off the shaft without doing any damage to the shaft. Everything that is on the market doesn't seem to work. Some of the pullers that are out there are your 2-leg pullers, triple leg pullers, and your bearing knives. There's not much that the customer has found that will work to remove the cones safely and effectively. One of the big issues with these style pullers is there's not enough height in the puller to actually use this correctly. It does become quite dangerous in some of the ways people use them. The other issue with this sort of puller is it pulls weight onto 3 points of the bearing cone and it knocks it out of shape a little bit, and it can actually interfere with removing the bearing cone off the shaft. They do work in some cases, but in this case, they're just not working for the customer. We need to come up with something so they can remove them evenly, distribute the weight as they're trying to pull them. And being that this shaft is about that long, there's not many pullers on the market that have legs that long to be able to pull that bearing off. Essentially what we're going to be creating is an overgrown version of your standard bearing knives. The issue with the bearing knives is they are quite thick. The ones to suit this bearing would be about that sort of thickness. Because of the size that the bearing knives are, you can't put them over the top. They interfere with the housing that surrounds this, and you can't get them underneath it because of the thickness of the puller. The other alternatives are you heat the bearing up and then you try and slip it off, or you hang the component upside down, you heat it and hope it falls off. The problem with using heat, if you're not real careful, you can damage the component you're trying to salvage. Failing that, you might have to cut it off using oxyacetylene or an air arc gouger or a grinder. Our customer did actually gouge off this particular cone. Trying to eliminate all those problems, we're going to manufacture them a puller that they can remove everything off it without having to use dangerous pullers, damage the components, or hurt employees. It's a 2-part component that goes in and grabs underneath that lip, and then they can actually jack that bearing cone off evenly, and they can use however long of threaded rod they want to act as the puller. So we're going to be making 2 pullers today, one to suit this larger bearing cone and then one to suit this smaller bearing cone. The piece of material we're going to be using, it's a piece of 40mm BIS 80 high tensile plate, and the smaller puller will be made from 25mm BIS 80 plate. We're going to get it set up in the lathe. We're going to use a 4-jaw chuck to hang onto this. I need to bore out the ID to suit the underside of the lip, and then I need to cut a 17-degree taper inside that to suit the cone. So we're going to get stuck into doing that. Righto guys, so I do need to punch a big hole in this thing now. I did forget to ask them to put that hole in there because I didn't actually know what size the bearing was. I didn't get it cut in there, so I'm gonna have to trepan that out. So I am gonna use a 4mm parting and grooving tool, and I'll just come in and just notch my way through as I go, and I'll end up with, say, a 200mm round, 40mm blank of material that I can then put on the shelf for another job. one more view. Doggy toy. Hang on. Here we go.
Give it to me now. What's it called? Is there a thing? Enjoy your gift. Thanks for the videos. James from Canada.
Thank you, James.
I want the bag.
No.
He's just like a kid.
No.
But I want the bag it came in.
Put the ball back in there. There you go.
Making a mess. Ooh.
Coffee. Rich and intense. Big thanks to Bill from Texas. He sent us some of his favourite coffee and we're looking forward to giving it a try. to me. Buckets. You got this. Righto guys, so we're going to cut the two bits of flat bar that go on top of the puller to actually hold them together. Being that you can't buy a high tensile flat bar, I do have a piece of 32mm high tensile plate, which is a BIS 80, the same as what the puller's made from. It is an offcut from a job, so we're just going to throw that in the saw and cut our parts out of that. Righto guys, so we've completed both of our custom bearing pullers. The smaller one was made pretty much identical to the way the big one was made, just everything was a little bit smaller. We were able to use standard size materials for that without having to make anything custom. The only difference between them, other than their size, is the smaller one has a 9-degree taper to suit the bearing cone, and the larger one has a 17-degree taper to suit its bearing cone. These will definitely solve our customers' problem with the issues they were having pulling off the bearings. The only downfall to using this style of bearing puller is one puller suits one size bearing. They don't suit any other bearing. So I'm going to show you how these things go together. Unfortunately, we can't show you the big one on how it works. Because the customer split the bearing cone off the shaft it was on, it has actually expanded, so it will not fit this puller. But we will show you the smaller one. It is the exact same principle on how the big one works as well. That's how it actually attaches to the bearing. The bearing still has a little bit of room to spin in there, so it's not actually clamping the bearing, making it any tighter. If you want to picture the way it works, let's pretend this is the shaft that the bearing is seated on and it's locked to it. So that's the shaft. You put in your pulling bolts in each corner. You can now put a porta power or a jack on top of the shaft, put your head plate on that, tighten your nuts down, and use hydraulic pressure to then pull the bearing off the shaft. The top plate that goes on the puller, the customer already has that. We manufactured one of them earlier on in the year when we made the other puller for them. So it has got slots in it, so it can be made smaller or larger to suit different size pullers. And then it also is machined to fit inside their porta power. So everything's lifted nice and square. With this particular design of puller, the customer has never had a bearing they couldn't remove. You don't get any binding, you don't have any dramas, the bearings just come straight off. So that's the job done. We're gonna get these back to our customer.
Yep.
Wait, righto guys? So how am I starting that? So start again.
Oh my god.
So we're gonna get it set up in the fuck me. Fuck. Oh, fuck, see, it's hard to explain that bit. Oh, fuck,
Stop.
it's just shit. Right. Fucking trains. Tell you what. The reason
Oh my god.
Yeah.
Oh my god.
It's a good thing. Instead of fucking small. Fuck off. What's the wobbler gone?
Ay, ay, ay.
That one.
Yeah, we don't know how to say it.
Big boots. Yeah, that one.
Yeah.
Very good.
Okay.
Coffee break.
Helps with finding how to open it. He just wants to rip the bag up. Stuff the toy. Homeless.
Hey, enough.
Get him. Look at this, he's trashing it.
Homeless. Enough.
So don't send toys, just send bubble wrap.